Okay, so let's get going here. I'm here today to talk to you about machine utilization and how to track and improve equipment performance. Huge topic. We can go down a lot of different holes here. I'm going to try to keep it direct to small and mid-sized manufacturers, specifically those that are using CNC type of equipment and either a job shop or a production type of a facility. So excited to kind of jump into that a little bit today. My name is Andrew Geisel with the Bearex team. I am the co-owner and COO of Bearex. And a little bit about Bearex and what we do. We are an industrial IoT platform specifically set up for small and mid-sized manufacturers, where we deliver live machine OEE and data that can be utilized in order to improve our production output, our throughput, and utilization. One thing that makes us a little bit unique is we operate as both the IoT integrator. So we're the actual team coming out, connecting to the machines, helping you overcome some of those technical hurdles that we run into in network situations. And then we also help provide the platform that you're going to be looking at from a data perspective and analysis perspective as well. And you'll see some of what we have to offer there as we go through this today. To get started, I'd first like to talk about why we're here and why we care about machine utilization and tracking this and putting energy into this. And what we are finding, we're located in Southern Michigan, in Jackson, Michigan. And what we are finding with most of our clients in the area is that there is an issue with profitability when it comes to making sure that we are utilizing our machines to the fullest potential. And what is a little bit deeper than that is a few things. One is we're finding that our setups are taking way too long and they're ineffective, mainly from a job shop perspective. Any data that we are pulling from a production statistics perspective is usually out of date. It's usually coming from a manual input. So operators keeping track of downtime, they're keeping track of reason codes, and they're capturing that, and then they're putting it into the ERP at the end of the day. The problem of that is if it was down for 3 minutes, maybe they didn't capture that. Or it was down for 38 minutes and they wrote down 30 minutes. Really inaccurate information that we need this information to make some crucial decisions off of. We also have a lack of visibility into the current state. And what this means is that we just don't have a benchmark. So we don't have any benchmark on where we're currently sitting. So any performance improvement or efficiency improvement priorities that we're putting in place, we don't have that benchmark in order to see the impact and profitability. And so that's a large issue, is we just don't have that. We don't have an ability to understand the factors that are impacting that utilization. And then we have that inaccurate data that's also impacting OEE. We're not able to pull that type of metric or look at that. I think one thing that's important to understand of how we as Bearex got to looking at machine utilization as our core emphasis and core focus. We started as a data company. We went into manufacturers and we said, hey, we saw this big need that they're collecting all this data in multiple different sources. However, they weren't looking at it from a collective, cohesive perspective in order to make decisions. That could be ERP production data, that could be financial information from accounting softwares, that can be quoting, that could be HR information. And what we found time after time that we pulled this data together, so much of the information that they're looking at to improve profitability came from the, let me hit this. There we go. It came from the data from the production floor, and they're using that information to make very large decisions. However, that data was inaccurate and not reliable, not live, very historical. And so we found that the best way to service our clients is give them insights into that information that they need. So let's talk about the solution. How do we overcome some of those problems? Number one is we need to capture data directly coming from the source, which is the machine. It's very black and white. It's always accurate as to what it's giving us, and it's giving us that baseline. And we need to remove as much data entry as possible and set benchmarks for ourselves. In doing this, we need to build this culture of productivity and machine uptime in order to improve our throughput and our profitability. Now, some of the benefits of where we need to go and why we want to look at this. One major benefit is that we need to look at the utilization as the lever to pull for profitability. There's a lot of different levers we can pull for this, but from our perspective, in years of collecting data that manufacturers are currently capturing, all of those make little adjustments, and the biggest lever that we can pull to have a direct impact is the machine utilization. Machines are our largest assets that we invest into, and the way that we produce revenue is making sure parts are coming out of that machine. So when you look at from a brass tacks, black and white perspective, it's our ability to make sure that those machines are producing that's going to give us our ability to make money. From a utilization perspective, everybody can impact utilization and look at this information. If you're looking at from a sales perspective, in order to know where we are at utilization and capacity, available capacity, we now know this capacity that's sitting there for us to quote effectively. We also can see, hey, if we quoted this part at 5,000 pieces and we're only producing 3,000 per week, that's an underperforming part for us. And so we can even look at it as an opportunity to shed some not profitable parts and bring in higher margin-based prices for ourselves, or parts for ourselves as well. So that's how sales can look at utilization and impact profitability. Talk about maintenance. For us to look at the utilization data coming from the machines is mainly the downtime reasons, and we're able to graph and chart and take a look at that data from downtime reasons and able to take a crack at the most lagging or nagging issues that we're seeing that's keeping us from our machines being up and running. Floor supervision, this is an easy one. Efficiency, productivity, right? Efficiency from an operator perspective. How can we support that operator? How can we keep that machine up and running and limit the amount of time it's down? Engineering, manufacturing engineering, we capture information on cycle times, setup times, tool change times. We're able to rate that specific machine on how it's doing in those areas, so it can gain direction and action for the engineering team in order to support that utilization and productivity. From a management perspective, we're able to see the open capacity. So we're able to see if it's time to invest into a new machine, it's time to open up a new shift, or we need work on our current efficiency, current setup times, and our current shifts. And then it also understands any poorly running machines in order to put energy and focus into. So when we look at this and how we deliver this, we look at it from three perspectives. First perspective is a shop floor view. So that's like a live view into the operations. If I just opened up the window, what's happening on the shop floor today? That's live. And then the other live one is the operator hub. So shop floor as a general, and then the operator itself from that work center where are we at as far as availability, where are we at as far as efficiency goes, and I will show you some of that here in a minute. The third is the reporting and analysis. So that we look at it more of a supervision perspective. It's not as much of being live as it is a little bit more trends in order for us to have some of that impact I talked about earlier. So let's jump into the shop floor. So part of these solutions, in order to understand and impact our utilization, is we need to connect directly to the source. So here's an example of different work cells. You'll see them across in this grid. These are different work cells on a manufacturing floor. Anything that is not gray, we are connected directly into and pulling this data and able to display it in real time, right? And so you can see this 96, 98, 121 across the top here. That is the internal nicknames of that work cell for our clients. This is just an example one. And you can see, if I just open this up, what's happening on the shop floor. Anything white is being scheduled down for the time being, and that's an automatic trigger. You don't actually have to go in and say, hey, it's scheduled down. It just automatically clicks over. The green is saying that it's actively running. Red is it's not running. Purple means on the operator hub they said, hey, the machine is down for some reason and I need somebody over to help come check it out. And the reason why we have that is because that helps us with our culture of productivity, that if anybody sees that purple, they can jump over and see why that machine is down and how do we support that going. So most of our clients have these on large TVs all around the shop floor. So anybody and everybody knows where we are live in the moment in order to have that impact. This is where I was talking about that shop floor supervision, in order to have that impact directly on machine uptime and our downtime. This is a screen that can be directly on that work cell. So this is an example of one that is connected to, the machine is connected. When somebody logs in, they're able to put in the part that they're running. They're able to put in the expected parts on what it is. And then that way we're able to track setup times. We're able to track expected versus delivered as far as part count or actual part count goes. And you can see on the screen is that it'll start ticking. So we're actually going to start to see how many parts they're producing based on where we should be for the specific cycle times and the expected parts you have. So we'll tell the operators, hey, you're X amount of parts behind or you're X amount of parts ahead. We're able to capture scrap and then also machine down reasons. So is it down because of a feeder issue, or whatever it may be? We're able to capture those. So we are able to then help maintenance and those other screens I was talking about before. And then those operator screens are able to display out on the large TVs. One thing, if I jump back, actually, these screens, it's important to know, we can put these on tablets around, like at the work center. We use industrial grade tablets and magnets, and we've kind of gone down that whole road to find really good ones that help, that work well in the shop in the mist and all of that. Or we can use already set up PCs, and it's just a URL that we can log into that the operators can use as well. So that's live in the moment, impacting uptime, downtime. If I go back to the benefits, that's mainly the supervision perspective, the shop floor supervision. Then we can get to some of the analysis that we can do as well. By pulling that information, we're able to see availability across different operations. So this is an example of a shop, and they have 4 kind of different sections of operations. This is the north section highlighted. Here's the different work centers, and we're able to see the availability. expected versus actual, and then the scrap. This is an example of live again. So this is actually based on the shift, where are we at and how are we doing. This is a great way for a shop floor supervisor or manager to take a look at a little bit more in depth to go and help and support the team that's out there. And one thing that's important, I didn't put together a lot of the analysis when I talks about like the sales and some more of the overall management. I wanted this webinar to be a little bit more dialed in to the actual live on the floor. How do we impact profitability in the moment compared to just analysis? And I think it's important to know that everything that we just went over, coming from the machines, we're able to pull and impact all of our components of OEE. We just hit availability, performance, and quality all in that example that we looked at. Now, let me talk to you a little bit about kind of how we do that and where that goes. OEE obviously is overall equipment effectiveness. It's kind of noted as like the holy grail metric for our operations. The problem with it though is everybody likes to create their own. They think OEE for them is very specific. We like to put a nice benchmarking across that. For example, availability. So OEE is the combination of availability, performance, and quality. Performance is made up of what's expected and what's actually being produced. Now, availability is where some of the customization occurs, and it truly is availability saying, is the machine running and producing a part or not? And that's it, period. Our machines are available 24 hours a day. It's true that they could be running 24 hours a day. So when we look at availability, we're going to look at it from 24-hour perspective. How much is it up and how much is it down? Now, your benchmark may be different based on your operations. If you want to run one shift, two shifts, if you give out free lunch or breaks, you can kind of calculate what that is. Your benchmark may be you can only get it as good as 90%. Or 50%. But the true availability for that machine is going to be based on those 24 hours. We're able to get that information by connecting directly to the machine, right? It's going to tell us, I'm producing a part or I'm not. That's it, black and white. When I look at performance, it's our expected versus actual. Our expected is going to be inputted by that operator as they start their shift on that screen. So I can capture that expected from that perspective. And the actual is coming from the machine itself. We can capture that data to say each time a part is produced, we can tag that and compare it to the expected to be put in. And then quality is our scrap. And that scrap from that screen I showed you earlier, that is inputted by the operator themselves. So then we're able to look at by machine, what is the OEE year to date, the last month, 7 days, and yesterday's overall OEE, and then break it down to availability, performance, and quality, and gives us some really nice data to take a look at and understand how we're able to impact our profitability from our utilization. Awesome. So getting a little bit into Bearex a little bit more on like what we do, how we're able to support, how we do this. You'll see machine monitoring type of products that are out there. This is a little bit of a sales pitch of Bearex and kind of what makes us a little different. One is that we use different data sources and combine them together. So we pull data directly from the machine itself, but we also combine that with some of those other data sources so we can capture true scrap, downtime reason codes, and provide more insights to other operations in the company in order to impact our profitability. Another one is that it's really easy to use with little to no training. You saw our screens, that they're very simple to understand. That is for a reason. It's harder to become simplistic than it is to just include all this data that we're capturing. We want it to be, when we put it in front of an operator at a work cell, it's really intuitive. I log in here. If I have a piece of scrap, we go here. Oftentimes, as we are implementing, we always do like a little pilot with our client, and we'll put out 5 tablets or 5 of those operator hubs. And before you even get a chance to train, they're already punching in, they're already putting the information in. So very, very intuitive. And then the third reason is we wear the hat for you. So we specifically support small and mid-sized manufacturers that most machine monitoring platforms are not suited to support. And it's because most of those platforms, the great platforms, however, they expect an integrator or the client themselves to integrate it, install it, support it. And as if you've ever taken on that project before, that's the largest hurdle, is the implementation and getting up and going and training. And so we specifically support small and mid-size. We understand your operations, understand the hurdles, overcome them, do the installations, and then also provide the platform as well. So how do we do that? There's a few different ways. One, we start with the pilot. So where we are the integrator, we map out your shop floor with all of the networking and connections and PLC information that we need. We can then understand kind of what the total investment's going to be. We do a little bit of a pilot. Pilot cost is around $6,000. From there, we can understand what implementation and scale would look like, and then we support that moving forward. Here's an example of an investment. If you had 40 connected machines, the pilot would be around $6,000. You're then able to, from a hardware and setup perspective. So like I talked about the tablets, we recommend certain tablets. There's TVs that we put on. A typical shop may have 4 TVs. A lot of times we need to replace or add to a network, or not replace, just add our own network in order to connect from a Wi-Fi perspective appropriately. And that, all that hardware and the setup for us to do that is right around 30 to 70 thousand. Obviously that's a large range, but it's either going from you need half of that or you need all of it. So that's kind of why there's that range. And then step 3 is the service and support, which at 40 connected machines is about $2,000 per month. The step 2, obviously the hardware and setup and the phasing it out is obviously the biggest investment here. The nice thing is the way that we set it up is we have a low cost pilot where you can understand the value and we can understand the complications of the setup and be able to price it a little bit better for you. So there's no commitment after the pilot from that perspective. And then if you're interested, obviously reach out to us. We would look at a machine sheet. So we take a look at what machines you have, PLC information. We get out on site for a couple hours, and then we would start mapping out what that implementation would look like. Then we'd enter into a pilot before that phased implementation as well. So I want to thank you for joining us today. We got done a little bit early, so hopefully I gave you some more time in your day and get back to it. Please reach out. I have my email there. Any questions that have came up or anything that you would like to see. I'll jump here in a minute to the Q&A for those who join live, and I can go into any depth and pull up some examples too if you need as well. All right, well, thank you all. If you're interested in the Q&A, just hang out for like 1 minute and we'll get going on that. Thank you very much.